We're continuing our discussion of Unit 8, Pretransfusion testing. The history of compatibility testing, in my opinion, is very interesting. In the early 1980s, we started to question the utility of a lot of different testing that we were doing. We started working smarter, not harder, using the science to defend decisions to eliminate certain tests from routine testing. For example, the routine use of anti-A-B and A2 cells in ABO grouping. When I entered the field, we used anti-A-B as part of the routine ABO testing. We were so worried that perhaps we might miss a very weak subgroup of A or B. Again, based on science, based on statistics, it was deemed that these are reagents that are in our toolkit, but not for routine testing. Repeat D-typing of D-positive donor units. If we get a unit in the transfusion service and it was labeled D-positive, but it's really D-negative, what does it matter? D-positive people can safely get D-negative blood. So for the D-positive donors, we no longer retype them with anti-D. Very much cost-saving in large transfusion services. Weak D testing. We're going to transfuse an individual based on the immediate spin reaction with anti-D. So if they type as D negative, we're going to give them D negative blood. Even if you did the weak D test and it was positive, how do you know that they are not the mosaic, the partial D, that may possibly form an immune anti-D? So again, weak D testing is no longer routinely mandated. It does have a place, but not for routine testing. DAD testing, direct antiglobulin testing. This is no longer a part of a routine test for compatibility testing. Performances of elutions, unless there are specific indications for doing them, we no longer have to do them. They're very time consuming and take a certain level of expertise. The significance of antibodies reactive at room temperature or below. Now we're talking about the significance. We're not talking about identification. But if we do have identified a clinically insignificant antibody, we don't have to do additional testing like phenotyping for that antigen. We can go by the cross-match. Usefulness of albumin in antibody detection tests. This was one of the first potentiators used for enhancing antigen-antibody reactions in the transfusion service, but better ones have come about. It's still a tool in our toolkit, but it's not used for routine testing. The use of AHG in both the antibody screen and cross-match. We'll talk about the different types of cross-matches, but in general, if you have an antibody screen that's negative through AHG, then a lot of places will not do a Coombs cross-match on the donors. During the years 1984 and 85, the FDA and the American Association of Blood Banks allowed the Coombs or AHG phase of the cross-match to be deleted if the patient's antibody screen was negative and they have no history of clinically significant antibodies. In 1984, Judd, another big name in blood banking, recommended deleting the autocontrol as part of routine pre-transfusion testing. An autocontrol is patient serum plus patient cells, and you treat it just like your antibody screen. And at the end, if it was positive, then you would have to do a DAT. How many times did I have exactly this happen? That I did an autocontrol, it was positive, the DAT was positive, and it didn't change the way I transfused that patient. So why do a test that will add additional unnecessary work? So again, working smarter than harder, the autocontrol is not part of routine testing. It is a tool in our toolbox for other types of testing. By 1986, the minor cross-match was a historic interest only. When I started the field, I did minor cross-matches, and this was donor plasma that was tested against patient cells to see if the donor had an antibody against the patient. So again, how many times did this happen? How much cost did it take to do these minor cross matches? And because we give packed cells only, why even worry about it? Let's talk about the cross match. Who needs a cross match? Patients who are experiencing clinical signs and symptoms of anemia. Patients who are actively bleeding. And if they're having a surgical procedure where the possibility of excessive bleeding is high, for example, a hip surgery. What is the major cross-match? It's patient serum or plasma added to donor cells. It's read at 3 phases historically at immediate spin. Then we add a potentiator and incubate it at 37 for a specified period of time. Then we wash it and we add anti-human globulin. This is set up and read as part of the antibody screen procedure. If you are doing a Coombs cross-match, you do not set up your screens and get them going and then get your cross-match going. No, that would be a waste of time and effort. You're twice washing cells 3 times, so you've doubled the amount of time to get blood to this patient. So when you're doing a Coombs cross-match, remember that you go ahead and type your patient so that you can select the donors, so you can set up your antibody screen and the cross-match tubes at the same time. Agglutination and or hemolysis are positive reactions. You always hold your tube and briefly glance at it to see if there's a reddish tinge to the supernatant fluid, because that would be positive. That would be hemolysis. And then you gently shake to determine if there's clumping. Donor cells reacting with the patient sample at 37 or AHG, or if the antibody has caused hemolysis, are interpreted as incompatible and cannot be transfused. We do not call these reactions with donor cells positive or negative. Absolutely not. It's either compatible or incompatible. The immediate spin cross-match. When no clinically significant antibodies are detected in the antibody screen, and there is no history of antibodies, the AHG phase of testing is not required for the cross-match. Rarely have I ever seen a Coombs incompatible cross-match obtained when an antibody screen is negative. You must demonstrate ABO incompatibility by performing the immediate spin cross-match. That is the only reason an immediate spin cross-match is done, is to confirm ABO compatibility. When you spin it down and you look and you have a 4+ reaction, you have picked the wrong ABO type for your patient. This policy change requires medical director approval, although because this has been done for 20 or more years successfully, it's no longer an issue. The decision to omit the anti-human globulin phase of the cross-match is based on the following. Incidence of incompatible cross-matches when the antibody screen is negative, and the reason. The sensitivity of the antibody detection procedure used. The benefits of omitting the anti-human globulin phase in the laboratory, and that's generally time and money because we're not using those reagents, and the expertise of individuals working in the transfusion service. If you have a very tiny transfusion service, then this may not be the option for you. You may decide to go with the full Coombs cross-match. If clinically significant antibodies are present, the AHG phase of the cross-match is required, and this has to do with the expertise of your personnel in the transfusion service. You must know that if a patient has a positive screen, they are not eligible for an immediate spin cross-match, because how do you know if that unit lacks the antigen to which that antibody is directed? You don't. So a Coombs cross-match is required. Computer cross-matches I have finally grown to be comfortable with. If the antibody screen is negative and a computer is validated on site to prevent the release of ABO incompatible blood, it may be used to detect ABO compatibility instead of serological testing. The following conditions must be met. 2 determinations of the patient's ABO group by a second type on the same sample, or a second current sample, or comparing to previous records. So what does that all mean? So if you have typed the patient, you've made your cell suspension and your serum, a second type from the same sample would be going back into the original sample for a repeat type. But a lot of places are now mandating a second current sample, meaning you will draw the blood with the cross-match, and if we don't have a historical type, then a second sample must be obtained from that patient and the type verified before releasing the blood. And if you have a historical type on the patient, a repeat type is unnecessary if they match. The donor ABOD type, the unit number, the component name, and the confirmatory type. The patient ABOD type, the antibody screening result, and 2 unique patient identifiers. And the method to ensure correct data entry. Believe you me, I was participating in the validation of our blood bank computer to validate all types of testing. A lot of work goes into it because we, as blood bankers, are the least trustworthy people you'll ever meet. And everything must be done so that I can go home and sleep at night that this computer is doing its job and not releasing ABO incompatible blood. A computer logic to alert to ABOD discrepancies on a unit label, and testing and ABO incompatibility between a recipient and donor. So all of these things must be met before a hospital lab can consider computer cross-matching. So here is the list of the optional pre-transfusion testing all in one place. For ABO groupings, these are optional. Testing RBCs with anti-A, or serum or plasma against reagent A2 cells. For D-typing, you do not have to do the weak D test, it's optional. And the RH control with chemically modified reagents unless the patient's an AV pause. So I will say this until you get sick of me saying this. The reason a D control must always be performed on an AV pause is you do not have a tube in the forward type that gives a negative reaction. So I'll say that one more time. The reason a control is required for AV pause is you do not have a tube in the forward type that gives a negative reaction. For the antibody screen, the indirect antiglobulin test, we've eliminated room temperature incubation. You don't have to use additives such as albumin or LIS, but you're going to double your incubation time. A saline test requires a lot more time for the zone of equivalence to be met. Enzymes and polyspecific antihuman globulin. That used to be our reagent of choice. It caused a lot of false positives due to nonspecific coating of cells with complement. Now it's a tool in our toolbox, but it's not used for routine pre-transfusion testing. Additional optional pre-transfusion testing, autocontrol or DAT. Published data indicate the performance is of limited value even in recently transfused patients. AABB standards does not require an autocontrol or DAT. Microscopic reading of test. A magnifier viewing lamp is adequate, although a lot of transfusion services that do the tube test will use the microscope tube reader. I do this, and especially for cord blood DATs, because it may appear negative macroscopically, even with the agglutination viewer, but microscopically you will see clumps. For the cross-match, the 37 and Coombs cross-match when the antibody screen is negative and the history is negative. Room temperature incubation, gone. Enzyme tests, gone. Polyspecific antihemoglobulin, gone. The minor cross-match, gone. Now keep in mind, these are tests that can be part of our toolkit, but are not required for routine testing. Selection of your donor group. When possible, you want to go with ABO identical. D positive should be selected for D positive, although D negative is acceptable but should be reserved for D negative except you have a D negative donor that's short dated, which means it's going to expire soon, and you have a D positive sure give, which means the doctor has not only ordered the cross-match, but has given orders to transfuse. We try to be good stewards of our blood supply. It's very limited, and rather than see a D negative die on the shelf, I'd rather transfuse it into a patient. If a D positive person has multiple antibodies present and a D negative unit will be more likely to lack these antigens, I will go with D negative. For example, if I have a D positive person with anti-big C and anti-big E, I can almost guarantee you that 70–80% of the donors I pick that are D negative will be negative for those antigens. D negative should be selected for D negative patients to avoid immunization to the D antigen. Consult with the medical director and patient's physician if the need is urgent. Use D negative first. What you want to do is weigh the risk of patient death versus immunization to D. They can live with being immunized to the D antigen. They cannot live without blood. It may be appropriate to administer Rh immune globulin, especially after platelet transfusion. Rh immune globulin is anti-D in a bottle, and it's a product given to women who are D negative and gave birth to D positive children. Platelets are contaminated with red cells, and we have a formula that we use. After so many platelet transfusions, we'll give this, one vial of Rh immune globulin. So again, it's used to prevent immunization to the D antigen. So memorize this chart. For group O, unfortunately, they can only get group O. B, they can get B or O, A or O. AB is known as a universal recipient. They can get AB, they can get A. The next choice for transfusion will be O, and the last choice for transfusion will be B. Why O before B? Because we have a lot more A and O than we do group B. So we want to save group B for our group B patients. There are times, primarily in emergency transfusions, that we have to administer non-type specific. In the current edition of the AABB technical manual, it states that once the patient's ABO group and Rh type are determined, the patient can begin receiving type-specific products. This is due to the use of packed cells that have very little plasma and therefore very little ABO antibodies. Institutions may choose to meet or exceed this requirement. For example, one institution states that if greater than 8 units of O packed cells are given, they will stay with group O. Another institution stated if a sample is drawn after emergency blood is given and a true type cannot be determined, they will stay with group O. For the purposes of this class, we will go with the AABB technical manual, which is the Bible of the blood bank, that once the patient's true ABO type and D type are determined, they can receive type specific. For other blood groups, meaning blood groups other than ABO, it is unnecessary to select units based on other blood groups unless the patient has a proven, clinically significant, unexpected antibody. If the antibody is strongly reactive, use the patient's serum to screen, then confirm with specific typing serum. I want to tell you that these typing serum are very, very expensive, and so a cost-effective means, if you have the time, is use your patient to screen for the donor units and then verify that they're antigen negative with the commercial specific typing serum. For a weakly reactive antibody where a patient's serum may miss a heterozygous cell, screen the units with the specific typing serum. If commercially prepared typing serum is not available, use the patient's sample, or if you have this available, plasma from a donor with that same antibody. A lot of donor collection facilities will save units of plasma that have antibodies because they can't give it to patients because we don't know whether the patient we're giving it to has that antigen or not, but they will store it frozen. Antibody detection technique used 2 to 3 commercially prepared Group O screening cells. Group O because they are ABO compatible with all blood groups. They have a relatively short shelf life of 2 weeks because some antigens will deteriorate on the cells, which may result in a false negative. An antigen profile, also known as an anagram, is provided with the analysis of antigens present on each cell. You want to make sure that your lot number of screen cells matches the anagram, because for each new lot number, they're going to use new donors. So the antigenic makeup will change. And nothing is sadder than you go to identify an antibody and realize that you have the wrong anagram, which really mucks up your results. You add patient serum or plasma to the screen cells and observe at 3 phases. Room temperature / immediate spin. So add your 2 drops and your 1 drop and then spin it. Read it, record it. After incubation at 37 degrees with an enhancement media, you'll spin it, read it, record it. And then the final step is after washing and completely washing, you add the AHG reagent. Agglutination and or hemolysis at any stage is positive. Now let me interject something here because I was fresh out of school when I got my job in the transfusion service, and I know they laughed at me because I was very green, and so I had done an antibody workup, and my supervisor asked me, well, where are the reactions for these phases for these tubes? And I said, well, they were positive, so I threw them away. I really applaud her for keeping a straight face, because if it's positive, no matter where, you continue to the next stage because you want to see, does it get weaker or stronger or go away? So regardless of a positive reaction at any phase of testing, you will continue on with those tubes. The phase of reactivity of a positive reaction is extremely helpful. There are certain blood group antibody specificities that react predominantly at immediate spin and then go away, and there's other blood group antibodies that don't react at immediate spin but react at the Coombs phase of testing. So this is an example of the anagram, and I really want you to spend time and look at your anagram. This is an example of a 3-cell screen. I love 3-cell screens because the chances of you having a homozygous cell is increased greatly, because sometimes weakly reacting antibodies only react with a homozygous cell. And this is why if you are doing an electronic cross-match or an immediate spin cross-match, it's really worthwhile to do a 3-cell screen just for that extra level of sensitivity. In the first cell 1 is R1R1, 2 is R2R2, 3 is the LR. This way we have all the Rh antigens present. And if you'll look, for example, in the Cal blood group system, cell number 3 is heterozygous for Cal. We have a cell that's heterozygous for KID. We don't have a heterozygous for Duffy, but by using 3 screens, you can incorporate more homozygous cells onto your screening test. The antibody detection procedure used is determined by what is considered a significant antibody. It's carefully considered if the Coombs cross-match is not performed. And once you adopt this antibody detection technique, it's written in a standard operating procedure manual and must be followed exactly by all staff members. Again, I can't emphasize this enough. This is not your little world. This is the world of transfusion medicine where patients' lives are at risk. And it is crucial that you follow step-by-step procedure that is listed in the SOP. Failure to do so could result in very serious consequences for the patient. The detection methods chosen should be, and I want you to memorize these three criteria, detect as many clinically significant antibodies as possible, because those are what can endanger the life of the patient if they have an antibody and they receive an antigen-positive donor unit. Not detect clinically insignificant antibodies. I don't want to see Lewis's or I's or P's or M's. And this is why we dropped the requirement for room temperature incubation, because that's when these guys popped up. And finally, allow prompt delivery of blood to the patient. You don't want your system to be so arduous and have so many tubes that it takes you 2 hours to complete testing to get blood to the patient. No, the patient needs blood now. So let's do our procedures correctly and get that blood to the patient. The antibody detection technique method should be sufficiently sensitive to detect low levels of antibody in the patient's serum or plasma. Undetected low levels of patient antibody may result in rapid production of antibody if antigen-positive cells are transfused. This would be that anamnestic secondary response where you have those memory cells that they start replicating and producing massive quantities of antibody. And again, antibody present in donor plasma will not harm the recipient, and we don't worry about it. The methods for the antibody screen and the cross-match may be the same or they may be different. Room temperature tests such as the immediate spin cross-match is required to detect ABO incompatibilities. They may not be required for the antibody screen. The antibody screen must include the AHG to detect clinically significant antibodies. The cross-match may be immediate spin only if the criteria for doing an immediate spin is met, and that means that the patient has a negative antibody screen. It is crucial that lab personnel use the same interpretations, notations, and consistency in grading reactions. Consistency in grading reactions is crucial. If I'm calling something a 4+ and you're calling it a 2+, you're shaking your tubes too hard. So part of your first initial training is to make sure that you consistently shake your tubes appropriately. Hemolysis and/or agglutination constitutes visible endpoint of the antigen-antibody reaction and must be observed accurately and consistently. Again, always remember to briefly glance at the supernatant fluid above the cell button. If there is red color to that, that is hemolysis, and it is a positive reaction. Use of a light source or optical aid to enhance the sensitivity and consistency. Yes, I can read using my eyes against a light, but I prefer the agglutination viewer because it has that mirror that gives me a much better view of small agglutinates. Microscopic observation is not required, but is useful to distinguish rouleau from true agglutination. For example, let's say your forward type is an AB pause and your reverse type is an O, then where's the problem? So maybe it is rouleau. So if you look at that tube under the agglutination, under the microscope, you can see that stack of coins appearance. And it's also used to detect mixed field agglutination seen in an antibody called anti-SDA, which we'll talk about later. Reactions must be observed for hemolysis and agglutination immediately after centrifugation. The manner in which the red cells are dislodged is crucial. You want to hold the tube at an angle so the fluid cuts across the cell button as the tube is tilted. The reaction is not interpreted until all cells are resuspended. I've had students that they're gently tilting, but there's a little button of cells at the bottom that's not been resuspended, and they'll call it negative. And I'll call them out on it. I said, you cannot call that negative until you have resuspended all of the cells. Because what if that last little bit isn't a glutamate? Overshaking will result in weak or negative reactions. And one thing I cannot emphasize enough is the reactions are recorded immediately with the tube held in the hand in front of the column where you're recording those results. You can hold 3 tubes in your hand. I want you to get used to reading 3 tubes at a time. But when it comes to recording, you don't resuspend them and then put them in your rack and then record them as negative. Well, Terry, they were all negative. Well, prove it to me. What are you making this determination based on? Well, those tubes over there. Yeah, the tubes are over there. They're not in your hand. So put them in your hand. Hold them right in front of the space where you're going to record that reaction. Or if you're doing the computer, I hold it up to the computer and then select my interpretation. You never write down an interpretation based on memory. Part 2 recording is in 2 parts. This is the end of part 1.